There are a lot of incredibly exciting things happening in two key areas of technology at the moment. The first is in the area of autonomous vehicles, especially on-road robotaxis and freight. And the second is in the area of humanoid robotics and robots and AI more generally. In this video, I want to cover what has been happening, especially in the area of autonomous vehicles and humanoid robotics, focusing on autonomous vehicles over the last decade or so, and much more recently, what has happened in the last few years in humanoid robotics. I want to spend a little bit of time comparing and contrasting what we've seen happen in autonomous vehicles to what we are seeing happen and may continue to happen in humanoid robots, because I think that's a particularly useful exercise to go through. And then I want to talk about how we may see it unfold in humanoid robotics and related technologies over the coming years, again drawing reference to what we saw and didn't see happen with autonomous vehicles. So to recap, autonomous vehicles, they've been a concept for about a century now, but the modern birth of autonomous vehicles really happened with the DARPA Grand Challenges in 2004, 2005, although we had highway driving autonomous vehicles even back to the 80s and 90s. And the race really took off about 10 years ago. It was arguably the biggest technology arms race in many areas for a few years. There was a lot of consolidation over the years. It became apparent that it was a harder problem than many people had predicted. It would take longer and be more expensive, and we reduced it to a very small number of players. Arguably, the leading player at the moment is Waymo, which is currently operating around 200,000 paid autonomous taxi rides per week. So if you extrapolate that at the current rate, although I'm sure they're trying to grow, that's around 10 million rides a year. And that's in a very small number of US-based locations. So arguably, the technology has got to the stage where technically it is more or less viable, at least in those specific scenarios. Now, I am not saying that they are necessarily adhering to all of the safety concerns, societal impact concerns. I'm just talking about the core technical viability of these systems. And this was really not a known thing until relatively recently, although a lot of people believed it would be solved. Now, can they make money from 10 million rides per year? That's not a huge amount of money, even if you assume, say, a $5 or $10 profit margin per ride. That's $50 million, that's $100 million. That, in the scheme of things, is not a lot of money. So again, the interest there, I imagine, is in scaling up and increasing that profit margin through scalability, through ever cheapening sensors, through making the compute more efficient, to reducing the amount of oversight and remote supervision that needs to be done with these technologies. But what we do have is we have a significant number of rides playing out every week. And so at least internally, I imagine those companies have some pretty stark and not dubious or not speculative at all numbers around the financial viability of these technologies. And that's something we really haven't had until very, very recently. The other large thing happening in autonomous vehicle technologies is pivots, and one of the key pivots at the moment is into autonomous or semi-autonomous and platooning trucking. The argument there goes that freight, especially truck-based freight in countries like the US and potentially my country like Australia, is that there are huge economical advantages to automating some aspects of that process. In part, things like having trucks that are always driving rather than having to take rest breaks, and increasing the flexibility of how you deploy your freight operations. That's at a much earlier stage. The initial moderate scale trials are starting to happen, but they are arguably a few years behind where the robotaxis are, although potentially there may be a greater economic edge in the area of freight than in the area of robotaxis. We will see over the coming years which of these is most viable. Humanoids are at a very interesting but noticeably different point in time to autonomous vehicle technology. So humanoids are a technology that have fascinated people and technologists and roboticists for many years, and they were pretty hot as a technology maybe 10, 15, 20 years ago. And then arguably there was a little bit of a rundown, a loss in interest in them, and that was sort of booted up again when we had companies like Boston Dynamics doing quadruped, but then humanoid robots with their Atlas robots. And in the last 2 or 3 years, it's really exploded. It reminds me very much, although it's different, of what we saw around the peak autonomous vehicle hype around 8-10 years ago. Now, what are the key things driving this change? Well, first of all, we have the popularization of so-called generative AI with the release of ChatGPT in November 2022, and more importantly, the systems behind these chat agents like large language models and now vision language models, and assortment of other types of these systems. And these systems have demonstrated a number of amazing capabilities, but two in particular are of interest to roboticists. The first is these systems, having ingested large amounts of data, tend to be able to act a little bit more like they have some degree of common sense understanding of the world. And common sense has always been an incredible challenge for artificial robotic systems. The second key component of these systems, and if you've interacted with one of these chat agents, for example, you would know this, is that they enable pretty sophisticated, pretty natural, iterative interaction with these artificial systems. And that is really essential both for training robots and for working alongside or being helped by robots, whether it is in a collaborative factory environment or whether it's in the home with a butler robot. Either one of these transformations by themselves is quite significant, but the fact that both of these capabilities have come along at the same time is really, really exciting. One of the big things that's being worked on at the moment is, instead of using generic data sets, training robotic specific large models. And so you're seeing some very well-funded startups, many of them actually are starting to do this and starting to get some results that indicate that this is at least reasonably promising. Now, there is a lot of debate around humanoids versus other robots. Ultimately, the argument in many sort of more industrial settings is you should customize and make your environment fit around and optimize the automation. This is a process that's been used very well in logistics, for example, where a large part of the logistics warehouses is built around facilitating the automation, and you often have the people around the outside of the workspace. Now, one of the arguments about humanoid robots is very similar to what we heard for software robotic process automation, in that humanoid automation can come into an existing workflow or process, and you don't necessarily have to radically change the entire system, the infrastructure, in order for that humanoid robot to be useful. So you have these competing viewpoints, both of which are correct in different contexts, of specializing the environment and the infrastructure to suit specialized bespoke automation, or having general purpose automation like humanoid robots that can come in and sort of do many of the tasks that people currently do. Another key discussion that is, or debate that is raging right now, is where potentially humanoid robots and related technologies will have their greatest initial impact. So a lot of the investment is going into the industrial factory manufacturing side of things, where the argument is that partly that robots like humanoids can fit into largely existing processes. You don't have to pay a robot, although there's some philosophical discussions about taxing robots as well, and you can achieve economies of scale of deploying millions of humanoid robots potentially largely into existing facilities, although they would probably change over time. The second major area of interest with humanoid robots and related technologies is more in the consumer space. So the classical example of this is the home robot butler that moves beyond what your robot vacuum cleaner does and is able to potentially tidy up your home, is able to maybe load the dishes, do very basic chores around the house, and help out that way. And there's also a potentially very large market in that space as well. The discussion around these two sort of large market options is very interesting because they have different implications and requirements of the technology. So to deploy humanoid robots in some manufacturing processes, you're competing against very fast, very highly skilled workers. And in many of these cases, the parts of the process that could already be automated have been automated already with what you call old school automation, but not necessarily humanoid robots. So one of the key questions there is, for example, if humanoid robots were to come into these environments, and if they are able to do some subset of the useful tasks, do they need to be as fast or faster than people to be useful, or could they potentially be slower but cheap and still be useful in these environments? And that is a relatively complex question to answer. It involves infrastructure and capital costs and the manufacturing processes and all those sort of factors. In the consumer application domain, at least in some subset of it, this question about speed is not so relevant. So we know that robot vacuum cleaners have really proven the point that it doesn't have to be as fast as a person, it doesn't really have to do as good a job as the person for it to be commercially viable. As long as it is able to do the job, perhaps when you're out of the house, perhaps a little bit slower, perhaps not so perfectly, so occasionally you have to go around and vacuum some of the corners, that is still a useful technology. And it's quite plausible that butler robots, for example, butler humanoid robots in the home, even if they're not as good as a person, might still be viable, especially if the cost of the platform comes down, and especially if other modalities like remote teleoperation, where needed, are made to work and are accepted by customers. Cost is a significant consideration here. In the early days of autonomous vehicles, there was a lot of focus on reducing the costs of the sensors, the compute, the vehicles themselves. Part of that has been helped by the popularity of electric vehicles, which forms the base for most of these autonomous robotaxis. And this same process is happening in humanoids. We have a very large number of dedicated or general manufacturers making humanoids, and the cost for a moderately capable humanoid, at least in terms of walking around, has dropped precipitously, where you can get one that's a little bit smaller than a human for sort of $10,000 or $20,000 US. And plausibly, this could keep reducing in cost. One of the aspects of humanoids that's really important to remember is there is a significant difference between a humanoid that can jump, dance, run, even do martial arts moves, and a humanoid that can do sophisticated physical interaction with the environment, picking up objects, manipulating them like a human would do. And we're starting to see a trend of more of the startup companies focusing on this enabling technology for humanoids rather than the core humanoid walking around type technology, which is arguably well on its way to being solved. A very interesting and useful contrast to draw between autonomous vehicles and humanoid robots is that there were really no plausible scenarios where you could deploy an autonomous vehicle technology in a commercially enduring way, where the technology's only sort of half worked. There isn't really a market for autonomous vehicles that are crashed sort of once a day, but because it's cheaper, you don't mind so much. It doesn't really work for both robotaxi applications, but also potentially for applications in defense, in agriculture, and construction, and so forth. This need for near perfection that dominated the autonomous vehicles commercial consideration is not present, at least for some subset of the humanoid commercial applications. And so that is a very noticeable point of difference. It means potentially you can deploy this technology in commercial applications a little bit earlier, even when it's not working perfectly, and then continue to learn from that experience and improve it over time. You couldn't really do this as easily with autonomous vehicles, especially the ones physically deployed in public environments. So what are we going to see happen in humanoid robotics over the coming few years? Well, it's undoubtedly a really hot field. One thing that's starting to happen, which is really interesting, is we're seeing some of the top technical talent, research talent, increasingly gravitating towards humanoid and humanoid-related areas, as well as AI plus robotics startups. So quite a significant fraction of the very top talent is either fully or at least partly associated with commercial activity like startups in these areas. Again, it's very reminiscent of what happened with autonomous vehicles around 10 years ago. The second thing we're going to see is that these companies and the VCs are going to speculate on a bunch of the most financially viable, most feasible short-term use cases. And not all of these are going to be correct. But when you hear of steps backward or things not being as successful in a proposed area, remember to keep that separate. That's a prediction. It doesn't mean the underlying technology isn't going to be transformative. It just means that the initial guess at where it was going to first have impact was wrong. It's really important to keep those two concepts separate. Another thing to watch, again, harkening back to the autonomous vehicle story, is the key companies working in humanoid robots, for example, are starting to roll out trials with partners. Now, we won't necessarily get public information, access to the economics of how well those trials worked, but nonetheless, somewhere in the system, people will start to get concrete hard numbers on their reliability, the frequency of how often you have to intervene, their actual cost to run, forgetting about the R&D cost, which of course has to be factored in. And so there'll be a lot less speculation, at least behind closed doors, than there was only a few years ago. And so we'll be in a much better place to get a concrete idea of the viability of these technologies. The other factor here, which is more of a socio-cultural factor I want to mention, is I don't think we can really underestimate the impact of starting to have potentially humanoid-like robots around us in significant numbers in both our workplaces and potentially our homes. Now, in this video, I'm not going into any of the implications for societal impact, the pros and cons, impacts on jobs, all of those sort of things. They're incredibly important, and there is a lot of attention being drawn to them. But from a sort of perception perspective, we don't have lots of robots around us on a daily basis, or at least advanced robots. Autonomous vehicles are slowly perhaps getting there, but that's still in a very, very tiny subset of the world. There is a real possibility that we might have humanoid robots physically around us, around many of us at least, in the next few years. I'm not saying it's going to happen, but it's now sort of not a 0% chance. And the sort of on-flow effects of that sort of transformation technologically, I think could be really, really huge. And if we manage it well, I think it could be really, really positive as well. So what's actually going to happen in the next few years? I don't know, but I think we'll have pretty good evidence in a few years about the viability of things like humanoid robotics. For the moment, there's going to be an incredible amount of excitement and investment dollars put into this area, and it's going to be really exciting to see, allowing for some hyping by CEOs, what these systems can and can't actually do.